Okay, yeah, thanks, Sean.
For coming. So as Sean mentioned, I completed the master's in NTU. My main research was on the creation of framework for the automation of involved carbon calculations in the interior architecture and Revit. So this is what I want to talk to you about today. And then I'll just quickly talk about how I brought this into my workplace and how I do it now as well. So my research essentially I did this in 5 months, and I was looking at the impact of interior equipment on the carbon footprint of a building and how can architects calculate it, especially using Revit to make things easier. Currently in our practice, we were focusing more on structure and envelope, but interiors do represent a significant part. So I wanted to look at that specifically. For this research, I focused on equipment that was architect specified, so nothing that the client brought on the side, and only the global warming potential. I'll come back to that in a little bit. So I'm sure you all have an idea of some of the terms I'm using, but just to give you a little bit of context, the embodied carbon that I'm looking at, so it's the carbon dioxide and the greenhouse gas emissions that are generated by the manufacture and use of a building. And it's split into different stages, so product, construction, use, and end of life. And this is what we're using when we're doing a life cycle assessment as grades. So we're calculating the environmental impact of a building over its life cycle. The typical life expectancy of a building we assume is 60 years, although we all know that that's not necessarily true. And when I was looking at those software that are available online for architects, there's very little in terms of interior architecture. So this, for example, is one professor, which I'm sure you've heard of, and really, in terms of finishes, they're looking at internal walls, the floor finishes, the ceiling finishes, but they don't really account for any of the equipment that's blocking the building. However, when you think about interior architecture, a building can be refurbished anywhere between 2 to 15 years on average. So if you take a restaurant or a coffee shop, it might be refurbished every single year, even to stay up to date. So we can see in the diagram, and it makes sense, the carbon footprint at construction completion of the structure will be much higher than the interior equipment. But what if we look at the lifespan of the building, so 60 years as using SCAs? So we can see in this diagram, year 0 represents when the construction was completed. So the structure and envelope side are quite a high proportion then, especially compared to the interiors in purple, which covers all the academy and the floor finishes and all those things. But you can see over the course of 60 years, you'll probably refurbish several times. So if we arrive at the end of life of that building after 60 years, actually the cumulative impact of interiors is quite high. So it's something that I think is worth considering from the start. So in this project, I was looking at environmental product declarations to source my data of sustainability. So if you don't know what an EPD is, it's a document that's created by a product supplier or manufacturer, and it assesses the product's carbon footprint. So it looks at a lot of different parameters, like the global warming potential, which is the CO2 equivalent per kilograms, and there's a lot, many more other parameters. It's created for any type of element, so it can be a chair, it can be floor, it can be a window, anything. And the trick is for EPDs, they are calculated per unit of product, which is where the Revit calculations kind of come in. So this project exclusively focused on global warming potentially just because of time constraints. So to come back on that unit of product, the EPD will give you the value for 1 kilo, but nobody really specifies 1 kilo of toilet or 1 kilo of anything really. So that's up to the user then to make that calculation. It's never included into EPD. You have to find how many kilos your toilet is worth, or you need to find that additional data and then go ahead and do that calculation. In addition to that, all EPDs kind of follow different formats, so you might have to do the totals yourself as well. So there's a lot of work involved for the user even after looking at an EPD. So in this example, you can see it will give you the total of global warming potential for that particular toilet. But you then have to go back on the website, to find the data sheet, find the kilos for that particular toilet, and then do the calculation yourself. So this is where my Reddit workflow kind of came in. I created shared parameters for all our families, and I sourced an MPV that was typical for our equipment and implemented dash data in it, and then I used the calculated parameters in Revit for Revit to do its own calculations by itself. And that meant that after I populated the entire model, say a school or hospital, Revit would automatically give me the total data for the entire building without me having to do anything extra for that. So just to test that, I suppose I used an exemplar project. So it was a typical hospital ward with 82 units. There were 1,300 items that were used, so it wasn't, you know, the total amount of items that would really be there in reality, but it was a good extract of what we were using. And I used one-click LCA to calculate a conceptual assessment of the structure, have something to compare it to. And then looking at the research I had previously done, I proposed a schedule of refurbishment over the 6-year period. And then I tested it, how would that work out? So, if we look at year 0, so construction stage, the structure and envelope in blue came out at 72% of the total global warming potential of that ward, and the interior equipment was only 27%. But then when you look at year 1 to 60, so after construction, once use is started, the interior items came up at 63%, which is significant. And then if you look at the overall of that, so including construction to the end of the life of the building, your envelope is at 58% and your interior is at 42%, which, so interiors are still a bit lower than the structure overall, but it's nearly half and half, which is quite significant. So that's something that's worth considering really at the start. Just a note there as well, in green would represent equipment that the client would add by themselves afterwards in the project, which we probably would have modeled, but they will go ahead and purchase it. So this would add then to the total values of the interior equipment. Now, of course, if the client is purchasing, we can only advise or give recommendation, and we suggest getting product with EPMs, but it's something to keep in mind there as well. So in conclusion, I suppose of that research is that equipment has significant impact on a building's carbon footprint over its lifetime if we look further than just construction stage. And Revit and EPDs can provide integrated values from early design stages. If we use that in combination with an LCA tool for the structure and envelope, it will give a really good overview of the carbon footprint of the building. Now, in terms of limitations, EPDs can be a little difficult to read, different formattings, low totals, there's a lot of additional work required from the reader's part. They're still in infancy, so not all products have an EPD. So if you're thinking of something specific, you might not be able to find it. In addition to that, when you're actually selecting your product, it might not be enough to select a product that has an EPD. You want one that has a good global warming potential value. But there is no easy way to see that. But because of an EPD, you have to go yourself and compare and do calculations. In addition to that, they're only valid for 5 years. So you probably have to update your Reddit families. You have to keep track of what you're using. In addition to that, in essay calculation, we use 6 years life expectancy as a baseline, but buildings don't really last 6 years. They often last much longer than that. They may have many more refurbishments. So if we were to take a real example of a building that's been used for 150 years, you can imagine the insurance would be significantly higher in terms of carbon footprint. And of course, there's the suitability of the projects. So my work is based on healthcare, so we use a lot of the same specific medical equipment. So it's a lot easier to approach accessibility on it. Whereas if you do, for example, a coffee or a restaurant, you'd be using a lot of different products all the time. So there will be a lot more research involved in that. So it depends on the project really. So that was my research project. I suppose a couple of words there on the sport and construction careers in digital and sustainability. So I suppose they really should be in college. You should start thinking about LCA and sustainability and how to use Revit. Springboard has great funding for further education. There's also a lot of new guidelines that are coming out now, that are worth keeping an eye on. We can imagine that in the future there will be new roles being created for architects and consultancy, sustainability and digital calculation, for example, and perhaps even artificial intelligence. In terms of where I work with O'Connor and architects, and we are quite involved in sustainability. So we are using life cycle assessment, etc. on because we completed the university strengthening PhD gym in the report there recently. And we used one to get CA calculations from the very start on that project. And we needed calculations after we completed it with the actual products that were used. So we were really able to show how much of an impact we made by changing the structure. And really being able to consider that from early on allowed us to make the right decisions. We shared that data with the Irish Green Building Council. We're trying to create a baseline really for a number of projects. So you can see this is the gym. It's quite a small project. We excluded DFFNE in that particular project, but this allowed us to really get a good handle on how LC work and how we can put this now on bigger projects. I suppose we're still looking at integrating EPD and sustainability data into our plans. Can we work with external consultants as well, rather than doing that in-house? It's a lot of work. Do some research on artificial intelligence and how to use it to help us in that way, and the sustainability leader as well is looking for new methods, I suppose, in construction.
Thanks, Dave.